Below you, absolute legends. Let's discuss the structure of ethers and a little bit of the naming. So an ether is when an oxygen is inside the parent chain of carbons. So we have like an oxygen atom here being flanked by 2 carbons each on each side right here. You also may see it drawn like this. Now in our group in chemistry just means carbon hydrogen chain. It could be anything out here. There's no element with the symbol R, so I think that's why we have R out there. Actually, I bet it has a German origin because a lot of OChem came out of Germany and Russia, so I wonder if it has an origin there. If you know, let me know in the comments. So here are some model kits trying to show ethers, where we just have a carbon in the center here. Excuse me, an oxygen in the center of the chain right here. Here's another ether. Just an oxygen, more or less trying to replace one of them right there. And just to compare it to a ketone functional group where you have a double bonded oxygen that's kind of out of the chain, or an aldehyde functional group where it's a terminal double bonded carbon oxygen right there. It's kind of the difference between ethers right here. Now the naming of ethers. Ethers have 3-word names. And the last word is always ether. So what these names right here is, this is always one side of the oxygen, and this is always the other side. Now there can be a reason for one side will take precedence over the other right there. But for right now, just looking at this one right here, this is an ether, because it has an oxygen in the center right there. And we have an ethyl. So we could say this is ETH. We could call this ethyl ether. Notice that they both end in "ill." But there's kind of no parent chain listed. They're both listed as substituents. Again, the most interesting thing about this molecule is never the carbon hydrogen. It's always something going on here. So oxygen is the center focus, so we kind of name these as both substituents here. Now, instead of saying ethyl ether, which has really great alliteration, sometimes you'll see di-ethyl ether. And this is the classic kind of knockout ether that you see in like old gumshoe movies with Sam Spade, where, you know, an ether-soaked rag, you know, the dame passes out. Some other ethers right here. We have, so now this is an asymmetrical ether. We have more carbons on one side than the other here. So we do kind of have a priority of which side comes first and which side we name second. We want to name the smaller side first. So this is methyl propyl ether. Now, sticking with some of our basic things about naming stuff, we want to make sure that the number of carbons in our name matches the number of carbons in the structure. 1 and 3, 1, 2, 3, 4. Okay, this matches up here. And there is a ranking with this ether system. We have the methyl, the smallest one, first, and the larger one second right there. Let's do another one. So here we have another ether molecule right here. Let's do this. So we have a branched substituent on this side. There are 6 carbons in this name right here. And I want to address this branched one right here. So we have an ether. So it's going to be a 3-word name, something, something, ether. We have 2 different sides here, and they're equal in the number of carbons. Let's name this side here first. This is going to be 3 carbons, so it's going to be propyl. Now this side over here also has 3 carbons, but if we note how instead of being, it is attached to the middle carbon of the 3. So this is called isopropyl. Now what iso is referring to, this is how I move it in my head. So I kind of unbonded it right there, okay? So there's propyl. Iso is taking that 1 carbon in and saying, now it is isopropyl. So that's propyl, and that is isopropyl. Let me compare it with this guy. This is butyl. That's isobutyl. Butyl, butyl for the 4 carbons, and that's isobutyl. I hope this helps. Thank you.